Hey guys, this is Fernando from R&H Audioworks. Um, I wanted to start making some videos to explain, one, who we are, what we do, how we do it. So if you know who we are, or maybe you've gone through our website, you'll see in our About section that we're two engineers. We love music. We're really passionate about designing and making things. And, something that was a hobby turned into something a little more serious. And then one day we decided to launch a small audio gear brand. We make mic pre's, we make EQs. We're working in some interesting custom projects. Right now, we're finishing a console. Next year, we have plans to launch a compressor. Uh, we love making stuff, and launching R&H Audioworks has put us in contact with a lot of good people in the world, from many countries, from many parts of the music industry, and it's just been a total blast. A total blast to get to know y'all, to get your feedback, to get to work on custom, really interesting custom projects. So we are really excited. We want to keep on doing what we're doing, and just want to take this opportunity to explain how we do what we do. So, prepared a presentation here. I'm going to go to the next one. Okay, so a really very basic high-level workflow. We go from idea, concept, desire to design. We're both engineers in our day jobs, mechanical engineers. So we'll go through what tools we use. Then we go through prototyping, testing, and then setting ourselves up to create the final product. You know, getting professional faceplates made, getting packaging done, and stuff like that. So it's really more like 7 steps. I've boiled it down to idea. Then the next step is sketching, coming up with the electronic side of it, schematics, figuring out the bill of materials, what parts we're going to need. Matt goes through extensive simulation and testing. Then Matt does the PCB layout. Once he's happy with the PCB layout, we decide to go and prototype. We do a lot of testing, characterization, meaning we start putting sine waves through it and then seeing what the response is on oscilloscopes, or just doing spectrum analyzer work. You know, just trying to figure out whether what in real life prototype is matching what the design intent was. Once we're happy with that, I'll do mechanical layout. I'll design the faceplates, the enclosure, the silk screens, and then we'll go to production manufacturing. We run small batches because mostly we're doing the work here in our little shop in the garage. So we go through production, and then finally go through testing, quality assurance, quality control. So in a little more detail, step number 1, idea. Matt, he's the brains. He's he comes up with the ideas, his brain and his wits. He's very passionate about recording music. He's has real talent when it comes to studying electronics, and so he's figured that out. And then through participating in blogs and forums, I think he gets a lot of ideas and inspiration from what he sees people talking about and people doing as well. So that's the first step. Then I have Matt show up in my office or at the house, and he'll be talking about this thing he wants to do, and he's been thinking about it for a long time. So he starts with a sketch, goes through block diagram, and then he gets into real, schematic, deciding what value resistor works here, what value cap, inductor, whatever that is. And then I know he does a lot of simulation. So some of the tools we use are Eda Software. We use EDA. EDA stands for Electronic Design Automation, web-based program where you can basically just draw the sketch or sketch a schematic, and yeah, just kind of schematic CAD program. His simulation, I know he uses SPICE program. SPICE means simulation program with integrated circuit emphasis. Awesome name. I don't know who came up with that, but I know he does a lot of trial runs and a lot of tweaking, a lot of iterations there, coming up with the design. So that's the deliverable of that stage is a schematic, a bill of materials, and a certain level of confidence that what he's designed is going to produce some sort of outcome. Then he does the PCB layout and EDA as well. And this is more of a geometric, just making everything fit. In this example, I'm showing you LH95 PCB layout, so it has to fit, conform within a standard. And then he does through all the layers, the whether it's multi-layered PCB and the masking and ground planes and all of that stuff. So once he's finished with that, we'll go in and we'll get a prototype. So we'll get a PCB made, and here on the left you can see this one is a through hole. We build them, and then I'll make faceplates out of wood or plexiglass sometimes so that we can mount them on our little lunchbox. And then we start, we power them up. Sometimes we have to troubleshoot. Not all the time everything works perfectly fine the first time. Sometimes we put caps in backwards and they explode. So it's always a lot of fun to go through prototyping and testing. And then the characterization, where we start getting response curves and then comparing that to the simulation, and then also comparing that to what the design intent was so that we can tweak and make changes. Once we're happy with the prototyping, we'll go through the mechanical layout. So at that point, we freeze the electronic or the electric design, and now I export the PCB layout from ECEDA, and I work with AutoCAD Lite. So here on the left, you can see there's a 2D plan view of the PCB, and then I create a front view or a side view. I go through all of the component reference text sheets and get the dimensions from there. We draw everything to scale, make sure that everything's going to fit, so that the faceplate holes or the enclosure is the right dimensions, the clearances are the desired clearances, so that everything works fine. And then I'll do the silk screen design. For our metal work or chassis or enclosures, we work with Protocase, a company in Canada. The nicest people in Canada, I have to say, are all in Nova Scotia. I really haven't met those many people from anywhere else from Canada, so don't get offended. But nicest people from Nova Scotia, great to work with. They have this CAD software that they've developed, 3D CAD program. What you see is what you get, so that you can go in and work, either take from a library of pre-built templates for enclosure types to just starting a plain 2D faceplate like I've shown here, the LH95. You can go through all of the holes and countersinks, whatever feature you want to add. They have libraries of catalog of things that you can use, and then doing the importing an image because they can silk screen or digitally print, and then you get a perfect preview of what you're going to get, and then you can immediately go in and get a quote for the part. So to this point, we've got to the point where we're ready to go and start producing. So then we'll order a bunch of PCBs. We'll spend days stuffing and soldering. We've explored both through hole and surface mount. Surface mount stuff makes it a lot more affordable to work in larger quantities. So we have now what looks like a final product. We have these really, really neat face plates, and then, like I said, we'll spend days working in the garage here, going through final assembly, final build, soldering, and then finally we go through testing QA, QC. So we have a little test rig, and then we start doing a lot of just getting response curves. So one of the pieces of software we use is Room EQ Wizard, which is pretty convenient, pretty nice. You have a real-time analyzer. If you want to, you can send pink noise, or you can send sine waves and get to see real-time. We used to have a fancy HP signal analyzer, but the power supply died. So, but now with computers, the capability of running FFTs real fast, this gets the job done. So it's really nice, because then we can save those files. If we ever have an issue down the road, we can compare and get a baseline. And that's pretty much it. That's how we do what we do. So if you guys have any questions, I'd love to get questions in the comments. Really been a great journey doing this RNH Audioworks. we've posted pictures on Instagram, and some of you have replied and have given us ideas and suggestions. I won't forget one time I made this one custom build where I had an L bracket, and one of y'all said, hey, instead of using that L bracket, you could use this other component, which makes the build a lot more robust. And I was blown away. I was blown away by how generous you all are, and I wanted to do the same. I wanted to sort of share how we do what we do, and if you have any questions, ask away. And yeah, hopefully we get to make more videos like this. So you guys take care for the holidays, and see you next year.